Good morning, grade 10s, and welcome to today's physical sciences session. So today is most likely going to be the last day where we have to fight with circuits. So I gave you guys some homework yesterday. I hope you did it. Before we start, anyone got any questions? We all okay? All confused as to when lockdown's going to end. You all hear my puppy in the background. Thanks, Ash. Let me just reset it properly. Right, now it should be working. Is that better, guys? Okay, cool. All right, guys. The moderator also sent me a little message here on the side. Okay. So this was what I gave you guys yesterday. Okay. Just remember to remind me if it starts lagging so that I reshare it. Okay. I have a feeling that my internet and my laptop is feeling a little bit like me. So we might have to just be very gentle with it. Good morning, Nelly. Okay, so yesterday I gave you guys this circuit and I said to you guys, you have to calculate that resistance, you have to calculate parallel, and you have to be able to calculate that current there. Okay, so before I get too sidetracked, because we all know how brilliant I do at that, let's get going. Okay, so we're going to do one first. So we're going to calculate the resistance in that top branch. Done. So these are in series. So for the top branch, we are going to say the resistance in series is equal to R1 plus R2, which is 5 and 7. So that gives us 12 ohms. Nothing scary about that. Well done, guys. Pretty sure you guys could all do that or get that right. If you struggled with it, let me know so that we can fix. Okay. Right, then the second part that I wanted you to calculate was the parallel component. Okay, so remember on your information page it says 1 over. You guys know why I hate that formula. So I'm going to say it's 1 over the top branch plus 1 over R3. Good morning, Carmel. To the power minus 1. And so we go 1 over 12 plus 1 over 3 to the power minus 1. Ashley got 2,4 ohms. Everybody get that? Who got something different? Anyone else get anything different? Oh, you guys still asleep. Good morning, Brayden. Miss P, you're like here, but you're not here. Where are you? Come on, did you get something different? Or are you okay? Latabo got, Anka got. You okay? Fantastic. Okay, so we got that. We're okay with that. Okay. So then I asked you to calculate the total current. Okay. We have to have total current. We need total resistance. and total volts, right? So I'm going to pop it down here. The triangle. Hey, look at that. That was a good one. V-I-R. We want current, so it's going to be V over R. Good morning, Darius. 9 over 2,5. 2,4. Sorry, guys, I wrote 2,4 and said 2,5. My apologies. 375. Everybody got that? Ashley got it. Anyone get anything different? Anka got it. You guys are like circus king and queens. I was very impressed. Very, very cool. Very cool. Well done. Hello, Miss P. Would you like sneaked in and died on us? No, Miss P. We just answered yesterday's questions. There's 1, 2, and 3. Okay, that's all you missed. And my puppy yapping in the background. Cordy Marie, you're not the only one whose Wi-Fi has decided that today is not the day. Okay, so guys, we're just going to be kind. Okay? Don't panic. You guys need to give your Wi-Fi serious talking to, because tomorrow we need to have like proper Wi-Fi. Because we're going to kick each other's bacons in Kahoot. I see it coming. Okay, we're all okay with 1, 2, and 3. Now, 1, 2, and 3 were the 3 that I said you guys definitely have to do. Okay? And then I said, well, 4 and 5 are challenges. Because Form 5 is not stuff we looked at previously. But I want you guys to start pushing yourself. See if you can figure stuff out. Okay, so for number 4, I said I would like you to calculate the current going through this bottom branch. Okay, now if we look at the current, and I know this current gets like really cray-cray, so let's try and simplify it just a little. I'll try and remember that I need to go back to that voltmeter there. If I forget, just remind me. Okay. So I'm going to try and clean stuff up. I'm taking everything away. All right. If we look at the circuit, okay? And I know this is a bit of a tricky question. What do we think? How much volts is going through this bottom branch? That's why I'm cleaning it up a little bit, so that we can have like a better idea of what's going on. How much volts do we think is going through this bottom branch? The electrons that choose to go through the bottom branch, how much energy does each of those electrons have, do we think? Come on, take a guess. Nine volt. Corley says 9. Anyone got any other ideas? Corley, the only one who's willing to risk it. Okay, guys, Corley is 100% correct. It stays the same, Kamal. That's a good way of thinking about it. So any electron, let me see. Now I'm obviously going to confuse my diagram again, but luckily. Okay, so electron that gets here has 9 volts of energy. If it goes up, then it has to split its energy between those two. But if that electron goes down, all 9 volts of energy can go to that 3 ohm resistor. Does that make sense? There's nothing else here after this electron's gone through the 3 ohm and it comes back up. There's nothing else here that takes any energy away from that electron. So that electron is happy in knowing it can give all its energy to the 3 ohm resistor. Okay. So over here, if we have to calculate the current, okay, we know that we have a 3 ohm resistor and we know that it uses 9 volts. Okay, we use this formula. We can say I is equal to V over R, which is equal to 9 over 3, which is equal to 3 amperes. So the maths is easy, guys, in this. It's the concept that you really have to like, okay, what do I have? What do I need? What's going to happen? Okay. Those of you who tried it, did you get 3 ampere? Oh, you guys are quiet today. Brendan got it. Larissa got it. Ashley got it. Corby. Carolina got it. Carolina, I'm very proud of you. I remember you really struggled. Tando got it. Well done, guys. Kamal got 1,83. Kamal, how did you get 1,83? Let me help you. Tyrese got 2. Oh, so Tyrese and Kamal did the same thing. That's fine, Tyrese. I'm trying to figure out where you guys went wrong. Which values did you use? Did you guys try and do a ratio thing? It's fine, Gordley, don't panic. Okay, guys, those of you who didn't get 3 amperes here, which values did you use? Did you try and use a ratio? No, hang on. I can fix. Is that a bit better, Miss P? Oh. Okay, Kamal, I get why you wanted to divide by 2. It's not a bad mistake to make. No. Guys, don't panic. Don't panic. Okay. So, everybody listen, because this is a good mistake for both Kamal and Tyrese to have made. Okay. It might be your network, Miss P. So I'm glad someone made this mistake. And I know this sounds terrible, but I'm glad you guys made this mistake because it means I can address it. Okay, so everybody listen up. Kamal and Tyrese said that if there is 3,75 ampere of current in the big branch, so in the whole branch, so there's 3,75 here, then Tyrese and Kamal said, well, half will go up and half will go down. And this is something that I know for a fact I haven't addressed, because I had hoped that something like this would come up somewhere, okay, so that we could talk about it. Okay, so Kamal and Tyrese, if you get to the shopping mall and you have to go to the till, which I know at this point is like a weird analogy to make, but anyway. If there's one line with only one person, and there's the line next to it with like 8 people, which line are you guys going to choose? So there's a line with only one person, and then there's another line with 8 people, and all 8 people have like big trolleys and lots. You're going to want to choose the short line. Good job. Okay. Now electrons are the same. Electrons want to choose the path of least resistance. Let me say that again. Electrons want to choose the path of least resistance. Now, Tyrese, that is not necessarily the 3 ohm because there's only one resistor. Okay, I get where you're going. But you have to look at the total resistance in the top branch and the total resistance in the bottom branch. So in the top branch, we have a total resistance of 12 ohm. And in the bottom branch, we have a total resistance of 3 ohms. That means that when an electron gets here, it will want to go here. It will want to go path of least resistance. Okay? Just like you would. But now think about it. The more people that choose the path of least resistance, what happens to that queue? It gets longer and longer and longer. So ultimately what ends up happening is more electrons choose to go through the 3 ohm resistor because it's less than the 12 ohm. So the current through the bottom branch is much bigger. But there are still electrons that are going to go through the top branch because they can see how many electrons are going through the bottom branch and it's become overcrowded. So they go, ah, you know what, it's fine, I'll just go through the tough queue. Does that make sense, guys? So the bigger current will flow through the branch with a smaller resistance, but don't think that all the current will flow through that. Okay, they do split. They just don't split evenly because there's less resistance. Okay, here. Corley Marie says that fit people will take the top branch and everybody else will take the bottom branch. Now, I disagree because if you give me the option of having a nap or standing for an hour, I definitely will choose a nap. Okay. But there are people that like standing. Okay. I see a hand up from Mr. Apocalypse Bird. You are more than welcome to type me a message, but yeah. Okay, Letabo. I'm glad that this came up. So Tyrese and who else did it? Kamal. Don't worry, you're fine, you're cool. Tyrese and Kamal, I'm actually very glad you guys did it because it's something that I hoped would come up, but never kind of did until now. And it's a good thing to make clear in your mind. Okay. Yeah. So Gordley says the top branch has got more hills to climb and the bottom branch only has like a little 3 ohm hill to climb. Okay. All right, guys. So that is the current. Now I am going to write this current in here. If I can find my pen, there we go. Because we need to know this current for the next question. Okay. So last question, and I put this in here to really, really make you guys think. Now, Kamal and Tyrese, you guys will get a different answer. Don't panic, okay? Because remember, your teacher would have still worked with your mistake. Right. So, if we know that the total current is 3,75 and the current going through the bottom branch is 3. What will the current be that goes through the top branch? Total current 3,7, bottom current 3. How much will go through the top branch? 0.75. Come on, just be careful. Don't round to 1 decimal, round to 2. Okay, so we can now say that 0,75 ampere goes through the top branch. So now I have the current through the 5 ohm. So I can work out the energy it needs. Okay, let me just pull it down here. I should still have some board left. Yes, I do. Okay, so let me just put that in a diagram for you guys. So we've got 3,75 ampere coming in. We know that 3 amperes go down. Therefore, 0,75 amperes go up. And we know that 0,75 amperes go through 5 ohms. And I want to know how much energy it uses. So I'm going to draw the triangle over here. So, ooh, that's a bad triangle. Clearly, I can only get one triangle right in a day. Clearly, because that one's even worse. All right. So I want V. So V is equal to IR, which is equal to 0,75 times 5. So I get 3,75. Oops. Volts. Okay. Guys, this is harder than most grade 10 questions will be. Okay? Most grade 10 questions, and sadly most grade 11 questions, don't put more than one resistor into a branch. So those of you, and again, Therese, Kamo, I'm glad you made that mistake. If we had had the opportunity of talking about it earlier, you guys wouldn't have made that mistake, and you guys probably would have all gotten all your questions 100% correct. Okay? So I want you guys to realize that you now have a very, very good grasp. Tyrese, that's all we can ask. When you learn something, I've done some of my job. Okay, guys, I want to point out that I now believe that you have an excellent grasp on circuits. Okay, so the only thing that they could do harder than this, but that would be exceptionally mean, is add another resistor here. Come on, that's cool. I love it when you guys learn from mistakes, which is why I say, like, I'd been hoping someone would have made the mistake earlier. No one did. But it's okay. We're cool. Okay. So, guys, just so that we're all, like, sorted, now, we've done where we have parallel, a big parallel stick, which is then in series to other resistors. And now we've done the really, really tough one, where we had resistors in series in a branch, which is parallel to another one. Okay. And I'm honest with you when I say that this is pushing the boundaries of grade 10 by quite a proper amount. Okay. But I did it on purpose because I know how amazing you guys are. I know how hard you can push. And I know that we generally do well together. Okay. So guys, I just want to quickly recap with you. Okay. In term 1, you guys looked at atomics and atomic models. And then when you guys started out with me, I gave you a crash course in the periodic table and how I kind of remember the periodic table. Then we also, yes, Ash, because we're one big family. We also had a revision on waves, okay? Because a lot of you guys asked me to revise waves, okay? So we looked at transverse, we looked at longitudinal, and then we looked at EM waves, and then we did energy of waves, okay? We also, for grade 2, no, for term 2 work, we also did the idea of balancing. Remember, you guys hated me. You said, I can't balance. It's impossible. Okay? We all got there at the end. All right. And now we've done the next topic, which was electricity and magnetism. Okay. Now, we didn't spend a lot of time on magnetism. It is not exceptionally important. Okay. So I don't want you to panic. The electrostatics we did, that idea of charge transfer, that's important. Okay. So now we have 2 options for next week. Okay. And I'm talking to you about it because the way I see it at the moment, unless something really weird happens, we are still going to be one big happy family at least next week, if not longer. Okay? So, we have effectively 2 topics left for the year. There's another one called chemical systems, like the hydrosphere, but you don't write exam about it. So I don't want to spend time on it. So we have 2 options. We've got physics and we've got chemistry. They are both equally tough. I am of opinion they're both equally fun. Okay. And they are both equally important going forward. Right? So the chemistry we have left is chemistry that is finally got some calculations in it. Okay. And it pulls together all the chemistry you've done this year. And it is vitally important that you know it going forward. Okay, so that's the chemistry. The other one we have left is called mechanics. So that's physics. And you learn about equations of motion. Okay. Now, I'm pretty easy either way. According to the pace setter, you know, the thing that tells me when I'm supposed to do what, we should be doing the chemistry. Okay. So I don't see any like solid arguments for physics here. Oh, okay. Sean threw a spanner in the works. Anyone else who wants to? Tyrese. All the girls are arguing for chemistry. Miss P wants the physics. Tyrese, you've already voted. Do a poll. Can I do a poll? Okay. I will do a poll tomorrow. Okay. And then we will argue about it. Okay. And then the poll will decide. Okay. Right. Guys, there is a probability now that we're going to end up doing it anyway. Like both of it. All right. So everybody happy with circuits? Is everybody feeling pretty confident about it? Like, cool. Yes. Okay. Is there anyone who wants me to go over a specific part of electricity that we've done that you're quite, yeah, like, not sure about? Everybody okay? All right. So, the last part I explained. Arthur, are you talking about the idea that the current doesn't split evenly? Is that what you're talking about? Yes. Okay, cool. Let's spend some time on that. I don't mind. Okay, so I want you to think of a resistor as something that makes it harder for an electron to move. Okay? So just like if I had a pipe and I made water flow through my pipe, okay? Okay, Miss P. Noted. We have the time, guys, so it's cool. All right, so Arthur, I'm going to simplify the branches for you just quickly, and then we'll complicate them again. Now, irrespective of how simple or complicated they are, the theory is exactly the same. Right. So, if an electron gets here, there's a whole bunch of electrons, they're flowing in the circuit. Guys, this is just a part of a circuit. Don't shout at me. I know it's not complete. It's going to take me forever to draw a complete circuit. So when the electron gets here, it has a choice. It can go up or it can go down. That is the nature of a parallel circuit. If this is 2 ohms and this is 4 ohms, then the first electron will definitely choose to go up because there is less resistance. It's easier for the electrons to flow through the top one. The next electron will probably still also go up. But now this third electron goes, but hang on, you guys have gone up because, yeah, okay, that line is shorter. But now there's more electrons in this top branch. So it's starting to get crowded, even though it's easier. So for me, for this electron here at the back, this electron is going to go down. Okay. So here, for the first 3 electrons, we had going up and 1 going down. So the smaller the resistance, the bigger the current. Okay. Now, there is a way that you can calculate it using ratios. I always get like ridiculously confused because it's like inverse of the upside down thing. Okay. Always remember that, say I have a 6 volt battery. No? Then that will be 6 volts. And that will be 6 volts. Okay, because this electron has got 6 volts, this electron's got 6 volts, this electron's got 6 volts. Each electron has got 6 volts of energy to give to each branch. Okay, so this electron gives this resistor 6 volts of energy and then it goes down. So this electron's gone up, and then it comes back down here. This electron's gone up, comes back down to the big branch. This electron's gone down, and then it comes back down to the big branch. So for the top, I can calculate the current as 3 ampere. And for the bottom, I'm going to use the same formula. 6/4. I think it's 1.5. Yes. Okay. So Arthur, what I want you to notice here, smaller resistor, bigger current, bigger resistor, smaller current. But now, do you guys notice this ratio thing happening here? You see it? Was everybody staring at me blankly? What do we see here? 2 to 4. If I simplify this ratio, what do I get? If I simplify 2 to 4, what do I get? Come on, guys, like grade 8 maths. There we go, a half, 1 to 2. Good, yes. Go. If I now take this here, remember it's 3 ohms through the 3 ampere through the 2 ohm resistor and 1.5 ampere through the 4 ohm resistor. If I simplify that, what do I get? Come on, if I simplify this, what do I get as a ratio? Come on. Come on, come on, come on. Carolina, a half, but the other way around. 2 to 1. So 2 to 1. Can you see what happens here? The ratio of the current and the ratio of the resistor is the same. It's just other way around. Ashley just had a light go on there. Okay, so Arthur, there is a way, and I know it's in some textbooks, there is a way to use ratios to calculate size of current if you can use the ratios of the resistors. But you have to remember it's other way around and it's upside. I can't. I've never ever been able to. And because I really struggle with it, I am always hesitant to teach it because I know if I struggle with it, then I'm going to struggle to explain it to you. Actually, no. Okay. You do not have to use ratios to calculate currents ever. You can, you hear the word can, but you do not have to. Okay. I know some teachers really, really teach it. Okay. Like I say, because there's this inverse upside down thing, my brain really struggles with it. My brain can understand small resistance, bigger current, big resistance, small current. But now if I have to take that from a ratio and then I have to use whatever this total current, whoa. Okay, my brain cannot do that. Okay. So that is one reason why sneakily I do not teach it that way at all. Okay. So tomorrow we are Kahooting. Okay. It is not compulsory Okay? You don't have to join the class. If you want to join the class, you don't have to play. Okay, I want to make that very clear. Braden, I am going to try and make 3 games. Okay, I'm going to keep them a little bit shorter. Okay, and the reason why I say 3 is to kind of give everybody who hasn't played like a chance to get into the flow of it. Because if you struggle with it in the beginning, like if I make one big long game, then you're never going to catch up. Okay, so I see lots of, ma'am, how does it work? So, Carolina, I have the same problem. Okay? Well, mine, technically speaking, is not my phone that's slow, it's my brain that's slow. Okay, so you have a couple of options. We've got a couple of minutes. I want to just run you through it. Okay? Is there anything else that's open that's taking internet or Wi-Fi that I need to close? Close that. And let's close the whiteboard. Let's see if I close everything, if this happens faster. Okay. Just double check that I'm sharing it nicely with you. Clearly I am. Okay. So guys, Kahoot is a game, right? I will make sure that I've got the Kahoot open and playing before we get there. Okay. Maybe let me close this as well and see if it doesn't take less Wi-Fi energy. Okay. So with Kahoot, you can play it online, so like in a browser like this, or you can download the app on your phone. Okay, for those of you who are lucky enough to have like a computer at home that you're doing the lessons on and you have a phone, okay, it makes it a bit easier. Okay, Braden says the app takes forever to load, so just be careful of that. Okay, but clearly at the moment, like all Wi-Fi and networks are hard. Okay, let me try. Oh, there we go. Okay, so guys, I am going to give you a game pin. Okay, I will set it and I will give you the game pin. I think this is the game I played with the Maths Lit people. Ah, okay, hang on, let me try a different one. Oh, that's why, because it. Try that one. Not. That one. That's one we played yesterday. Ah, again. Oh my goodness. So I'll give you a game pin. Okay. Let me just see if I can. Oh, there we go. Okay. So I will give you a game pin. Okay. Yes, so Braden and Tyrese says use your browser because it's faster. So you are going to get, if you go to kahoot.it, you're going to get to a screen like this. Okay. And then it's going to go ask you for a game pin. Okay. I am going to create the game. So I've got the game pin. Then the screen you see is going to have 4 blocks on it. Okay? After you've put your pin in. Now this is where it's handy to have a second screen. And that's why I'm saying we're going to play it more than once. Okay. so that you can get the feel of how to go from one screen to the other. Okay, because you need to have the Zoom open so that you can see the questions. Lusa Sedi, I will give you the pin tomorrow. Okay, I still have to set up the games for you. No, it's like 1:45, dude. Oh, sorry, Tyrese. I read that as a question and not a statement. Whoa, very not working. Okay, so tomorrow I'll give you a game pin. Okay, and then on this screen, once you put the game pin in and you've added your nickname, then you're going to have 4 blocks that you choose from. And then on the Zoom will be the questions. Okay, right. So the topics, I am going to not have too many like serious calculations. Okay. It's more going to be theory, but I will never ask you for an exact definition. Okay. So for tomorrow, you need to go through electrical circuits. Right. So we're going to do Fun Kahoot on electrical circuits. If there is any calculations, I will give you more than enough time to do them. Okay. And just wink, wink, nudge, nudge. I do get mean. And I do sometimes make all the options are the right answer. I'm not saying it's always, okay? But if you get to a point where you go, but that could also be right, don't panic too much. Okay, guys. So tomorrow's Friday. We are going to Kahoot, okay? We're going to have fun. I will set up a poll as well for the chemistry versus physics for next week, okay? You guys have done an amazing job the last 2 weeks. I'm super proud of you. Okay. I will see you tomorrow. And we're just going to have some fun tomorrow and we're going to be lekker competitive. Okay. We're going to enjoy. All right, guys, you good? Bye.